In this lesson, we'll extend your Plotly toolkit to include bivariate graphics. Specifically, you will learn how to explore associations using scatterplots, stacked bar charts, and boxplots. In this lesson, we'll explore a sample of 325 wines taken from the wine quality datasets on the UCI Machine Learning Repository. Here, we have the results from both a chemical analysis and assessment of the quality. Scatterplots allow us to explore the relationship between two numeric variables, such as the residual sugar and fixed acidity in wine. As before, we begin by piping our dataset into the plot_ly command. Next, we specify that residual sugar should be mapped to the x-axis and fixed acidity should be mapped to the y-axis. Finally, we add a markers trace to plot a point for each ordered pair. Stacked bar charts allow you to explore associations between two categorical variables. For example, we can explore how the type of wine is related to the quality label. To begin, we count the number of wines for each combination of type and quality label. Next, we map variables to the x-axis, y-axis, and color of the segments. In this example, we map type to the x-axis, N to the y-axis, and quality label to color. We add the bars trace as before, but we have to refine the layout in order to create a stacked bar chart, since the bars plot side by side by default. To stack the bars, we modify the layout of the bar chart by specifying bar mode equals "stack." The stacked bar chart of the counts we just created is useful for comparing the total number of high, medium, and low quality wines across type. If, however, we are interested in comparing the distribution of quality between red and white wines, it may be more useful to plot proportions on the y-axis. Changing from a stacked bar chart of counts to a stacked bar chart of proportions is a data manipulation problem, which is solved in 2 lines of code. First, we group the table of counts by the x variable, which is type in our example. Next, we use mutate to calculate the proportions within each group and store it in the prop column. So far, we've talked about exploring associations between either two numeric or two categorical variables. Boxplots are one way to explore how the distribution of a numeric variable may change based on the level of a categorical variable. For example, here we see that the distribution of alcohol content is positively associated with wine quality. Higher quality wines tend to have higher alcohol content. Of course, there is substantial variability. To create this set of side-by-side box plots, we map the quality label to the x-axis, alcohol to the y-axis, and add a boxplot trace. Throughout this lesson, we focused on how to create specific charts in Plotly. During the exercises, be sure not only to practice creating these charts, but also to spend some time interacting